Right, and we are live. Let me just put this down. All right. Hello, Dr. Brett, or if the TAs are watching this, my name is Joshua Hockmeister, and this is the code. So basically what we have here is the beginning of my code. And for this project, I wanted to have some fun, and I wanted to make a system that kind of stored variables known as failure, and it would just keep track of how many times or how egregious users would input incorrect statements, and it would keep track of everything. So I actually had a previous recording where I went through all of the code for that, and it was very long. I think the whole recording with this section and the section of the actual logic of the code for the main project was like 30 minutes. So I'm going to cut this down really, really short. Basically, right here at the very beginning, obviously we have our failure variable set to 0 because the user hasn't failed yet. And we have just the general greeting statements, your X inputs, press 1 if you want to see the rules, press anything else if you don't. Just a quick little if statement right there. Um, but then the actual logic gets into right here. It's just a bunch of if statements. Your CC is going to be your character color. It's just your input. It says what do you want your character to be, 1, 2, or 3. Just some simple if statements right here. And then this is right where it gets into the fun of it, where I start keeping track of the failure variables. So like I said, I'm not going to get too much into it because it took a really long time to go through all the different scenarios. But basically, the gist of it is that there's a failure variable and that each time you fail, it updates. And depending on if your failure variable is like 1, 2, or 3, you get a bunch of different while loops that have different responses. So you can play around with that a bit more. But moving down here past all of these, obviously after your character color, you have to input your character shape. So right here, what do you want your character shape to be? Square, circle, diamond. All the codes right here, just really simple if statements. And then, like I said, you get your failure variables, all there. It just does unique responses. So then we go all the way down to here, and then there goes your wall color. So I also have another variable, your failure wall color. That just helps to consolidate all the failure variables into one. So as you can see right here, I had a failure 1 and 2. If you have that, it just makes your failure WC1. If you had a failure 3 or 4 up here, it makes your fail WC equal to 2. So basically, this is just, a fun way to just have some fun coding this. And if you're a user and you like to intentionally input wrong inputs, you can see the chain of logic through that. So basically, yeah, it's just your normals. If your wall color is 1, 2, or 3, it's just gonna do your fprintf like, yeah, your wall color is black, wall color is green. And then I did another thing too, so where it's like if your wall color is random and your character color is random, it'll do some unique responses as well. So moving past all of this logic, as you can see, there's a few unique responses. Um, Moving past all this logic, getting into the actual game. So if your wall color, whatever the user chose for the wall color, it's just going to be assigned to an RGB matrix. So right here, if it's 1, it's just going to be 0, 0, 0. 2 is 0, 1, 0. You get the gist of it. And then this one is just going to be random for random. So getting into the actual logic of the game, right here I have a matrix that has all of the subplot wall coordinates that are possible. So basically, why I did it that way is because I was plotting. If we go all the way down here, I have it all commented out right now. While I was plotting all of the rooms and the subplots, I noticed that there was a pattern going on in the subplots. As you can see right here, there's like a 00220, and that repeats itself. I believe it's somewhere down here. Yeah, as you can see, it repeats itself here. There's a lot of these repeated. So I took out a piece of paper and I wrote down every single combination that you see here. And I got it down to, I believe that there's 8 of them. And I just made a big matrix of all of them. So I can extract all of those coordinates whenever I need them. So if we go all the way back up here, yeah, here's the matrix for it. And then so after that is created, you did the subplot of the first room. It's going to plot basically the outline of it with a black outline, and then it's going to it's going to plot this, and it basically just it's going to fill in the first wall for the first room, and then with that WC variable for the wall color that the player chose. And so now we have this little for loop right here that basically makes all of the rooms dark. So it's going to do basically a subplot. It goes through. So this II value is the same for the for loop, and it just goes through all the other rooms, and it just makes sure that they're all black for the game to function as intended. And then right here, right after that, is where I decided to put the key combinations. So I basically have this big matrix called key values. Row one is going to be your X values, row two is your Y, and then, sorry, row three right here is going to be all of the rooms that are possible for the combinations. So I have a variable called key random, and that's basically just going to be a random number generated with the randi command 1 through 8 for the 8 other rooms besides your starting room, because the key can't be in the starting room. And basically, that just is going to be used as the column for each thing. So for your key X coordinate, your key Y, and your key zone, it's going to be 1, 2, 3 that corresponds to the rows in the key values matrix. And then this key random is going to correspond to the random column that's selected for what you need. So basically, that's the key logic right there. Then moving on, we just have a really simple if statements that matches what the user input chose. So like your character shape and your character color, whatever they chose for it just matches it up to what it actually should be. So right here, if they put 1 for their character shape, that's going to obviously match it up with the square. Um, and then right here as well, you have the randi commands being stored as the CC. So it just stores the random color so it doesn't change every time. And then that's just some pretty simple logic there. So right after that, it's going to plot the first room, or sorry, not the first room, your character, like quote unquote spawning in. So it's going to plot your 1, 5 coordinates, your character shape, and then obviously your character color. And so now we're actually moving into the logic of the movement. So this took me the longest time. I spent so long on this because the main problem that I was running into is how do you account for backtracking? So I had this whole list of a bunch of while statements looping back, and it was horrible. So I thought to myself, I can make this a lot better. So hopefully this is a lot better. It's probably not the most optimized, but it works. So right here we have a variable D that just keeps track of the while loops. We have your zone trackers. And then right here is your YY2 and your XX2. So these XX and YY values I'll get into a bit later, but they basically keep track of the last position of your character. And it's important to set them here as Y is 5 and X is 1 because that's what the starting position is. And that's for room 1. That's going to be important for movement later. So basically, when you enter the first while loop, it keeps track of your movements because at the end of the game, you have to display what your movements are. And then it makes and then obviously D is going to be 1 to enter into this while loop. This one basically just is a safeguard against misinputs. So it doesn't loop through the entire thing if you did a misinput. But right here, this AA matrix, I just did zeros, 9, so it just preloads it faster. But this AA matrix is actually going to be extracting the room coordinates from A. And then obviously, we already went over this. This is the first while loop that safeguards against misinputs. I got to go quick here, run out of time. So right here we have this zone counter. So the way that I did my logic is I accounted for every single movement that you can make. So basically, if you're in zone 1, you have this statement right here. State is input. So you could do 1, 2, 3, or 4 for your movement. And then whatever you inputted for your movement, 1, 2, 3, or 4, this whole logic chain basically adds 4, or it adds multiples of 4 depending on what zone you're actually in. So say I'm in zone 3 right here, it'll add 8 to whatever input I added. So this just keeps track of the various different types of movement that you need for each zone. That's how I did it at least. So now we have an if statement for every single possible output that you could do for that. So there's like 30, I believe there's 36 if statements that account for every single movement. But a lot of them are very similar. So I'll just go over the basic logic for that. So obviously, if you can't move a certain way, it'll just fprintf if you can't do that, and then it'll re-go through the loop, and then give you that same options of movement right over here. You're currently in this zone. Which way do you want to move? But if you do have a valid movement, what it does is it takes the y1 is the first y position in the first subplot. Y1 is the second position in the first subplot. Y2 is the first position in the second subplot. Y2 is the last position in the second subplot. And this is important for the for loop for movement. Your zone gets updated, and then your steps is obviously accounts for if you're going up or down for Y direction or left or right for X direction. And this AA matrix right here basically extracts the coordinates, like I talked about earlier, from the A matrix, and it just matches up the actual room chords that you're going to need. So the logic is exactly the same for everything, just for X's and for Y's. It does the exact same thing. It takes your first position, your second position, and then your third position, fourth position for each one. And then if you can't move, it just gives you your can't move statements. So that basically sums up the logic for all of these 36 if statements. And then we actually get onto movement. So for the movements, if these states have been activated, these are all the inputs that can produce X movement, as you see right there. And basically what it does is it plots, it goes to the subplot that your original zone was in. It holds it on, and then it basically plots your character. So it goes through your YY2, which was your original. So say you're moving in the X, it keeps your original Y position, and then this II variable actually changes your X position. And then it whites it out to give the illusion of movement. So it'll put your plot here and then white it out, and then immediately it'll put your plot down here so it'll look like it's going down. And then right after that, it's obviously going to make the previous room dark, and it's going to light up the next room, and it's going to fill it in with all these plots. So as you can see, there's all the AA matrix that it extracts from the AAs that are all different for each if statement that you have here. And it just the reason why there's 4 as well is because that's the maximum amount that you can have, at least for my code for room 5. And right after that, it checks if your keys, it checks if your key zone is equal to the zone. And if it's not, it just keeps going. But if it is, it's going to just plot the actual key itself right there in that zone. And then after that, it's going to finish the movement right there. That's the second phase in the movement step. Then it's going to plot your last final position right there. Otherwise, it would turn white and you wouldn't see anything. And then there's some logic right here. So basically, right here is important for now. So if your key zone is equal to the zone that you're in, it's going to say that you found the key, and it's going to set your key value equal to 10. Now, the reason why you see a key value equal to 10 up here and the zone equal to 1 is because you have to get to zone 1 after the game goes. So the while loop will keep going until you've reached this if statement, then it'll break it and say that you've won the game. And so the logic is exactly the same for the Y movement as well. If your state is 2, 6, 10, as you can see all there, that's all the inputs that produce Y movement, and it's the exact same logic as the X movement. So all of this is exactly the same. And so basically, if you got the key and you got back to zone 1, breaks out of this, and you go to the last for loop, that'll just run the random color 3 times. So it's a double for loop right here, and it just basically goes, all through the subplots, and then it runs it 3 times. So yeah, basically that's all my code. Sorry I had to go a bit fast in the end, but I am running out of time. But if you do want to see all the logic for the failures, just please let me know. But anyways, let me get this up. Oh, no, sorry. There we go. I hope you have a great rest of your day, and thank you for listening to my video. Bye.